this is a brief introductory video on how you can train the SSD MobileNet offered by the TensorFlow API in order to detect dump trucks in videos. These are some of the files and folders that we will be using for the training purpose. I will go through what all the contents of these files and folders are as we go through the video. So images folder contains the images that we will be using for training. So right now I have 10 images of dump trucks that I have compiled as a sample data set just for the sake of this particular video. In a real life training situation, you would require at least 300 images of the object that you would like the model to make detection on. So if you want to detect, say, cars from videos, then if you want to train the model on detecting cars, then you would require at least 300 images of that particular objects that is properly annotated. So right now I have just 10 images, and I will be using this particular data set throughout the video. I'll be using this to train the SSD net, and I'll be showing how we will annotate each and every image. And after annotation I will be using an 80-20 split for the actual training and testing. So I would train the model on 80% of the entire data set, and I will be testing it on 20% of the whole data set. So right now, since I have 10 images, I would use 80%, that is 8 images to train the model, and 20%, 2 images to test the model. So that's how the training and testing phase would be. For annotating the images, we will be using a tool called label IMG. So this folder contains the associated files of label IMG tool. So this is the main file which you can run from a terminal, and it is required that you should have a proper installation of OpenCV in your system to properly run label.img.py. The model's master folder contains the main training and testing script and all the associated backend files of the SSD MobileNet offered by TensorFlow. So model masters is the main repository in the TensorFlow API GitHub page. So this is the actual folder. This is the main folder that we will be using for training the model. Training folder contains some associated files that we'll be using to fine-tune as well as properly use our model. So object detection.pbtxt file contains details of what sort of objects we are trying to detect in videos. So let me just quickly open up and show what exactly it contains. So since in our case we are trying to detect dump trucks in video, object detection.pbtxt will contain the label of that particular object under the tag name, and it is given an ID 1. Since we have only one object, that is dump trucks, we are giving it an ID of 1. If you have, say, multiple objects, say you have to detect dump truck, a ship and a car, then it would be ID 1 would be dump truck, then 2 would be cars or any other thing, like it depends. So you always start with the ID 1 because 0 is assigned for background class. So what SSD MobileNet actually does is, while the training process is going on, it samples negative patches from the training data set. So negative patches means which is not included within the bounding box annotations that we have generated. So you will get to know what is bounding box annotation and label file generation as we progress through the video. But right now what you need to understand is the background class in SSD net is automatically assigned the ID 0, and the background class would be populated with random patches of the background extracted from the images inside the training set. So that was the contents of object detection.pbtxt. Now we have the SSD MobileNet V1 configuration file. So the configuration file contains all the parameters that you can use to fine-tune the model. There are several parameters like the shape of the input image that you want to give, the batch size. There are several of those parameters that you can fine tune and you can change in order to uh, tailor make the model to your particular use case. So for example, in our case, we are only trying to detect dump trucks in videos. So for us, there is only one class of objects, so we will assign the num classes as one. So these are some of the changes, that one of the change that would come in our case. I'll go through the most important parameters that would come in handy as we progress along the video, so that you will get a much better understanding of what all these parameters actually mean. So next we have the generate tf record.py file. So this particular script is used to generate the TensorFlow record files from the annotations that we create so that we can properly train the model. So tf records actually is the way in which we provide TensorFlow object detection model with the training set. So TF record actually contains information of what your training data is, what your training data contains, and TensorFlow record files actually help us feed these information into the detection model while it is training. Next we have a file called support.txt. So what support.txt contains is some support script that would come in handy when you are when you are training the object detection net multiple times. I will get to it in a short while. I'll explain what is the contents of this as we progress through the video. Next is the xml to csv.py file. This particular file helps you convert the XML label files that we generate using label IMG into CSV files. So we will be having multiple XML files after the annotation process is completed, and what XML to CSV does is it compresses it into a CSV file, and it makes the TensorFlow record generation much more easier. So after executing XML to CSV and generating the CSV files, we would be executing the generate tf record.py file. So let's get on ahead with the annotation process. To do that, go into the label IMG folder, open a terminal there, just activate your OpenCV environment. For me it is CV, so source activate CV, since I am using Anaconda, and I have an environment by the name of CV, which contains a proper installation of OpenCV from the source. Let me go ahead and execute the label IMG script. It's quite important that you should be root in order to run this properly, because it has some issues running when you don't have root permissions. So this should open up the GUI. Yes, there you go. This is the label img.py script opening up the label IMG tool. So here you have the option to either open a single image annotated, or you can use the open dir button to load images in batch. So if you have certain images inside a folder, you can use the open dir button to actually do that. It will load up all the images in batch. Let me go ahead and do that, because that's exactly what we require. Let me quickly go to that particular folder. Okay. Okay, sorry for the delay. Uh, okay, as you can see, all the images have been loaded up in the right side window. So as you can see, we had 10 images in our video, our folder. So the those images have been loaded up, as you can see, and you can easily skip through these images back and forth with the next image and previous image button. You can do it even while you are annotating it, that's okay, but make sure that you save your changes each time you draw a bounding box. But if you forget that, that's okay. The tool will automatically generate an error message when you have unsaved changes and you're trying to skip through images. So you got that covered. So let me go ahead and start with the annotation process. So the annotation process is quite easy. So in the left side, this particular tab, you have a button called create rect box. If you click that, you will get cross like this, and you can use this particular cross to draw bounding boxes across the object. So right now you know that the truck is in this particular position, so you can go ahead, click on the image, drag it across the object just so that the square box actually covers the entire object that you are trying to annotate. Then you can enter the label of the particular object that you have annotated. So for us it's dump truck, so let me go ahead and type that in. So I have created a bounding box on top of a dump truck, and I'm naming that particular bounding box as belonging to the dump truck category. Let me go ahead and press OK. So see, as you can see, the bounding box is generated, and the label that is assigned to this particular bounding box is dump truck, and you can check that in the uh, top right pane called box labels. So you can also adjust the size of the bounding box as per your wish. You can use the corner arrows to actually do that. And once you have finalized the position of the bounding box as well as the labels, you can go ahead and save the model, save the annotation, and you can go to the next image, repeat the same thing, create bounding box, draw the bounding box across the object, name it accordingly. For us it's dump truck, and save it. So what is happening right now is that the this particular tool is generating an XML file that contains the details of what the object is, and it contains information of the bounding boxes. So the XML file would contain the information of the top left coordinate of this bounding box. So the XY coordinate of this particular red dot that is on the top left corner would be there. It would also contain the information of the coordinate value of the bottom right vertex of the this particular bounding box, and it would contain the detail of how big the image is and also the class label. So here the class label is dump truck. So these are some of the information that is contained inside the XML file that is being generated. So let me quickly go ahead and draw the bounding box, save it, next, create rect box, next. So you can also do multiple annotations inside one image itself. So say for example you have two trucks inside one image. Say see this particular image for instance. So I have a truck on the corner which also I want to annotate. So what you can do is you can again click on create rect box, and you can draw the bounding box and generate the and assign the labels as you did before. Save it, and next create a rectangular box, annotate, save, and click next. Okay, there you go. We have annotated all the 10 images inside our images folder. Now we can go ahead and close this particular tool, and let's see if the annotations have been generated. Yes, there you go. So corresponding to each image, you have an XML file which contains information of the bounding boxes, the objects inside the bounding box, and also the size of your image. Now we can go ahead and convert these XML files into CSV by running the XML to CSV.py script. And before doing that, we need to split our data set into training as well as testing set. So here, as I've told you before, I'll be doing an 80-20 split of the whole data set, and that means I will be taking 8 images for training and 2 images will be used for testing. And please note, this is just a dummy data set compiled just for the sake of this video. If you want to train it on a real life detection task to detect a particular object, then make sure that you have at least 300 images of that particular object before you start the training, and do the train test splits accordingly. So let me go ahead and copy 8 images as well as their um, annotation XML files. Yes, that's it. Let me copy it, create a new folder, name it train, copy all the files there. Again, copy the rest of the 2 images plus their XML files, create a folder called test and paste it there. Okay, there you go. We have we are completed with the train and test split. Now we can go ahead and run this particular XML to CSV.py script. Before that, let me show you what the particular code contains. So the main changes that we would have to make in order to get the annotation CSV files for a newer data set would be to modify the image path. So in our case, it's already images, so the images are inside the images folder in our main root folder. So all the images as well as the XML files plus the training and testing split is inside the images folder. So if you have it inside a different folder, make that particular change in the image underscore path variable, and the XML to CSV file uh, will create the CSV files in any particular folder that you prefer. So right now by default inside the code, it's pointing to a folder called DAT or DAT. So what that will do is when you run the script, the XML files will be taken, it will be compressed into a CSV, and it will be saved inside the DAT folder. So we don't have that particular DAT folder in our root folder. So let me quickly go ahead and create a folder called DAT. You can name it any name you want. Just for convenience, I'm using a DAT. You can use data or any other name of your preference, but make sure that you make the changes here accordingly. Okay, let me quickly go ahead, save this file. Let me close it. I'll open up a terminal, and let me just quickly run this Python XML to CSV.py. Okay, successfully converted XML to CSV. So as you can see, we have two messages. So what that means is one message actually points to the successful creation of the train labels.csv, and the other points to the successful creation of test labels.csv, since we have a train and test split inside the images folder. Let's go ahead and see if the files are created. There you go. You have two files, the train labels as well as the test labels. Let's see what are the contents of train labels and test labels. Okay, there you go. This is the contents of the train labels.csv file. It has the names of all the 8 images that we are going to use for training. It contains the size of those images, as well as the class label of the object it contains, and for us it's dump trucks, and these are the corner pixel values of the bounding box that we generated. So these are the xy coordinate. The first two values are the x and y coordinate of the top left corner of the bounding box, and the last two values are the bottom right xy coordinates of the bounding box. So that's how the train label is generated. um, it's similar with the test labels, only difference is it will contain information of the test images, and right now we are using only 2 images for testing. So now we have the test and train files properly created for us. Now we can go ahead and run the generate tf record.py. So that will generate the TensorFlow record files that we will be using for training the SSD net. Let me go ahead and activate my TensorFlow environment. Okay, it's done. Let me quickly run that particular piece of code. Let's see what the output will be. Okay, TensorFlow is loading up. Okay, import error, no module name object detection dot utils. Okay, so as you can see, it is showing an error that something is missing. So why this happens is that because we are running this script for the first time after restart. So what happens is you need to go inside model masters, and you need to reinstall the object detection API again. So that's how the TensorFlow API actually works for now. Hopefully they will come out with a fix for that, and this is the reason I included the support.txt file in here. So it contains some support scripts that you can run if you ran into some errors like this, like no module name object detection found, or at times you might get an error saying no module named development is found. In that case, what you need to do is, let me quickly open up the support.txt file and show you. So it contains 3 lines of code, and the 2 most important ones are detailed in line 3 and 5. You can use the script, use these particular piece of code whenever you run into similar kinds of errors with the TensorFlow API. So what you can do is you need to move into model masters, research, and just quickly copy this first line of code. And you need to run sudo python setup by install, that is the code given in line 5 of support.txt. It's the same thing. So you need to install object detection API one more time. This usually happens after a restart, or if you have changed the particular folder which you previously used to install the TensorFlow API. So if you installed it from a different path previously and you're trying to run it from another path after a restart, the similar error might come up. You can get around that error by using the support.txt file. So that's why I said it will come in handy as you train the model multiple times. Another mistake I made while running the generate tf record.py file previously was that I did not supply the path to where the train labels or the test labels.csv file exists. For us, it's inside the dat folder or the dat folder, and I did not give that information into the generate underscore tf record.py file through the terminal. So you should keep that in mind. You need to specify where your train or test labels.csv file is, and also the location to where you would like the TensorFlow record files to be created. So all that information and the corresponding script can be corresponding line of code can be found inside the generate underscore tf record.py file itself. So in line 5 you can find the particular piece of code that needs to be executed in order to generate the train record, and in line 7 you have the script or the code to be executed to generate the test record file. So first I want to create the train record, so let me go ahead and copy that, open the terminal, let me paste it there. Now the changes that you need to make is you need to properly specify where you require the train record to be created. So for me, I would prefer it to be created inside the dat folder. So let me make that change, dat. So right now the output underscore path points to the dat folder, and a file called train.record will be created inside that folder, which is the actual train record tf record file that we will be using to train the model. And the CSV file exists inside the dat folder itself. So we previously created the train underscore labels inside the dat folder. So the CSV underscore input should point to that particular path. So I have made that change, and let's go ahead and execute it and see what's the output. Okay, successfully created the tf records inside dat folder. So I have created the train.record file inside the dat folder, and now I need to create the test record file. So for that, let me copy the code mentioned in line 7 of generate underscore tf record.py, copy it, paste it there, make the appropriate changes. So I want the test records also to be in that folder, and my test labels are present inside that folder, so I need to make that change too. Let me execute it. Yes, so the test and train records have been created. Let's go ahead and see if that is the case. Okay, there you go. You have the test record file as well as the train record file, and these files will be used for the actual training process. So now we can go ahead and inspect the training folder. Let me quickly open it up and show it to you. So the main change will be to the SSD MobileNet V1 underscore pets.config file. As I have told you before, this particular file can be used to fine tune the model, also like change the hyperparameters of the model before training, like the input path to where the TensorFlow record files exist, the batch size you want to train the model on. So if you want to feed in like 10 batch of images per step, then you can make all that changes inside the SSD MobileNet V1 dot configuration file. Let's inspect this particular file in a bit more detail. Okay, these are the parameters that governs the model, and the main changes that we would be making in our case would be uh, to the number of steps, the batch size, the fine-tune checkpoint, the input path to the train records, the label path to the object detection.pvtxt file that I showed you before, and also the path to where the test records is present, and things like that. So let me explain each and every one of the changes that we are making to this particular file. So as I've told you before, the num classes is actually set to 1, because we are only detecting one object, that is dump trucks, inside this particular model. The next change that we can make is the number of steps you want to train the model for. So right now it's set to 1000. Say for example you have too much data with you and you prefer to train it for much larger steps. Say you want to train it for like 10,000, 20,000 steps. In that case, num underscore steps inside train underscore config is the parameter that you need to change in order to make that particular change to the training process. So right now let me go ahead and say that I need to train my model for 2000 steps. Okay, so num underscore steps have been changed to 2000. So the next thing we can change is the batch size. So if you are training it on a very very low powered machine, if you have a laptop with you, then the RAM and the memory limitations within the laptop will be like very huge. So if you have like a 4 GB memory stick, or if you have an 8 GB memory stick, and while you're training the model you're experiencing memory overflow, and errors like not enough memory, running out of memory, and all those errors, then batch size would be one reason that might be causing such a situation for you. So what you can do is you can reduce the batch size if you have hardware limitations. So when I'm training on my laptop, I ideally use batch sizes like 10, or I would go below some value below 10, and the performance increases like huge. So batch size is one parameter that you can tune. It says like how many images need to be fed into the model in one step. So if you have say um, uh, 10,000 images, and you have set your batch size to be 10, then you require 1000 steps in order for the model to see all the images. So you have 10,000 images, you have set a batch size of 10, and you need to see, or you need to go through 1000 of those batches, 1000 unique batches, so that the model actually sees the entire data set. And 1000 is the iteration, or the number of steps, and seeing that particular um, image or that particular data set once by the model is called an epoch. So right now for us we have 2000 steps, and we are giving a batch size of 10, but the model automatically takes care of all the math behind it. So say if you have some odd or even number of images, some random number of images, and uh, you need to figure out what sort of step size or batch size you need to give in order for you to train your model properly. That is actually not required. You can set the number of steps as per your requirement and the batch size as per your requirement, and the model takes care of all the backend calculations on its own. Even though you have some random number of images, some huge number of images, you need not concern about um, how to set these parameters properly. The model takes care of it automatically. um, Next particular thing I would like to discuss is the fine tune checkpoint. So the fine tune checkpoint is used for implementing transfer learning. So transfer learning technique is where you have only very small data set, but you need to train a model to do some classification or detection or some sort of prediction on that particular small data set. So the problem with training the model from scratch on that small data set is it would either overfit, or if you train it too much, or it will underfit if you train it very less number of times. So one uh, ideal thing you can do is you can take a model that is already trained on a huge data set, take the weights from that particular model, initialize that weight in your neural net, and on top of that weight try to train your model with the small data set that you have. That way you can make sure your model is not overfitting or over learning on your small data set. This is used to make the model more generalized. So right now what we are doing is we have the SSD MobileNet base weights provided in the TensorFlow GitHub repository. So that particular model file is initialized as the base weight for SSD net, and it's inside SSD underscore MobileNet V1 Coco folder inside the model masters main folder, and model.ckpt is the actual model file, and we will be initializing this model uh, before starting the training, and we will be training on top of this makes sure that your model is more generalized and it's not overfitting on your small training data set. Another variable you can you should modify is the input underscore path. So it should point to the folder which contains your train records. So for us it's dat slash train dot record, and I've made that change for to the input underscore path, and label underscore map underscore path should contain the path which has the um, pbtxt label file, the file which contains the id as well as the name of the object that we are trying to detect inside the video. For us it's dump truck, and I've shown this object detection.pbtxt file in the beginning of the video, and it's inside the training folder. um, Another variable you need to change is the input path to the test records. So for us it's inside dat folder, so I'm pointing it to dat hyphen test dot record. So that's it about the SSD MobileNet V1 pets configuration file, and let's quickly save this file, save the changes that we have made, and let me go back to the main folder. Okay, so we are done with the data creation, the data annotation, data creation, data split, and All the data management part for training the SSD net is completed, and we can go ahead and copy all these folders. That is the folder which contains the test and train records, the images folder which contains the images, as well as the train and test splits that we have made previously, and the training folder which contains the configuration, as well as the object detection pbtxt ground truth label file. Let me copy that. Let me quickly go into model masters, research, object detection, and let me paste it there. Okay, I already have a dat folder, so let me merge it, apply, replace. I think I had a previous copy of dat and the training folder inside the object detection folder already, so that's why I had to merge. Yeah, so we have successfully copied all the three folders inside the object detection folder. Now we can go ahead and start the training process. So for that we will be using the train.py script. Let me show you what exactly is inside the train.py script. Okay, there you go. This is a script that we will be using for the training process, and the method or the code that you need to use in order to execute or begin the training process is mentioned in line 18 of this train.py file. So in 18 you can see it's Python train.py, and you can supply the folder which contains the folder which you would require the train.py script to generate the model in. Here I am pointing into the training folder that we just copied. You need to supply the model with the particular configuration file that's also inside the training folder for us. So I have made that particular change, so it should point to the SSD MobileNet configuration file that we have modified and copied into the object detection folder. Let me go ahead and copy this piece of code. Copy. Let me use this terminal. I need to move into model master, research, object detection. All right, we are ready to start the training process. Let me go ahead and paste this, the script that we have already copied. So for me, I'm running Python 2 right now, so let me make that change. I am running Python 2.7 for this particular video inside the TENS environment, so I need to make that change. Let me execute it. TensorFlow is loading up. So there we have it. We have done with the training process. Now all the model files, the corresponding checkpoints and everything will be saved inside the training folder. Let me quickly open it up and show you what exactly the folder contains. So these are the checkpoint files, and I already have a model that is trained for 1,25,000 steps, and for this video I'll be using the model trained on 1,25,000 steps to generate the inference graph. So the inference graph is the actual model file that we will be using for the evaluation purpose. That is the actual file we will be using while testing it out on real-time videos, on for testing it out on images, etc., in order to detect the dump trucks or any object for that matter. So once you are done with the training, you need to use the model.ckpt files that is generated during the training process, and use them to create what is called an inference graph, and this is used by TensorFlow API to make detection on real life images or videos. So since I have a model trained on 1,25,000 steps, I will be using that to create the inference graph. And to create the inference graph, you can use the export inference graph.py file. Let me open it up and show you guys what the contents of that particular file is. See, as you can see, the file contains the support script that you need to execute from the terminal for generating the inference graph. In our case, we'll be using the line piece of code written in line 54 of the export inference graph.py file. I'll explain the arguments one by one. The pipeline underscore config underscore path should point to the configuration file that we previously used for the training process. So we use the SSD MobileNet V1 pets.config file, and it's inside the training directory, and the pipeline config path is pointing to that particular configuration file. The train checkpoint prefix file argument should point to the file which you would like to use to generate the inference graph. As I've said before, I would like to generate the inference graph on top of a model that is trained for 1,25,000 steps. So my variable should point to that particular model.ckpt file. So if you have a model that is trained for say 1000 steps, you would have a file called model.ckpt hyphen 1000. So in your case, if that is the scenario, then it should point to the model trained on 1000 steps. For me, it's 1,25,000 steps. So let me make that change, and the output directory argument should contain the folder where you would like the script to generate an inference graph. I would like to generate the inference graph inside a folder named dump truck underscore inference underscore graph. So this variable is pointing to that particular folder. You need not create it beforehand. The script actually takes care of it, and you can name your folder whatever you want, but keep in mind that folder needs to be copied into the location where you are actually testing out your object detection script. So I will explain it in a short while. So let me copy this piece of code, copy that, open the terminal. TensorFlow is loading up. It has created the folder. Okay, converted 199 variables to const ops. So that means the inference graph is successfully created, and you can see it. The dump truck underscore inference underscore graph folder is created, and it contains the actual model files that we can use for the real life testing of the SSD net to detect trucks in videos or images. So what you need to do now is copy this particular dump truck inference underscore graph folder to the main folder, which contains the script that you will be running in order to detect dump trucks. Move into the object detection directory in there and quickly paste it there. So now you have your dump truck inference graph inside the object detection folder, which is residing in the main folder that contains the main file which we use to execute the dump truck detection as well as counting task. So and one more thing you need to change is the variable that points to the inference graph. So here you can find the model name, and this should point to the folder which contains the inference graph you generated recently. So if you have a different folder, say just dump truck, that contains the inference files, and you have copied the dump truck folder into the object detection folder inside your um, root repository, then this model underscore name should contain only dump truck. Since we have our inference graph generated inside a folder dump truck underscore inference graph, we need to make that particular change. So that is the only change we need to make each time we generate a new model. So once you have trained your particular model with the SSD net to detect any particular object, you will have all the model files inside the your training directory, since that is the directory you wanted the files and checkpoints to be generated, and you mentioned that while you did the training process. So all those files will be generated in that particular folder, and afterwards, using all those model or model files, you need to generate the inference graph. And once the inference graph is generated, you need to copy it into the object detection folder, and also you need to make the change in model underscore name, that is line 36 in the main file. So there you go. Now you have a model that can be used to detect trucks or dump trucks in videos. Thanks for watching.